Look up. Wherever you are right now, you'll likely see a cloud drifting overhead. It appears calm, quiet, almost lazy, simply hanging there as if it has no other place to be. However, here's a surprising fact. That cloud could weigh over 1,000,000 tons. This isn't an exaggeration or a figure of speech. It's literally true. It contains enough water to fill thousands of swimming pools, enough mass to destroy buildings, and enough weight to flatten entire cities. Yet, it floats effortlessly, with no ropes, engines, or visible support. Just air. Today, we're exploring a seemingly simple question that leads to one of the most amazing stories in physics and weather. How and why do clouds float, despite weighing millions of tons? That's what we will be unveiling in today's video. However, before we continue, permit me welcome you to the channel, and yes, we know curiosity brought you here. This space satisfies that curiosity by exploring the strange, forgotten, misunderstood, and deeply human tales found in history, science, and the lives of real people. If this sounds like something you'd enjoy, then consider subscribing to the channel for regular videos that will always leave you nodding your head after watching. Now let's move on to the story. When people first learn that clouds can weigh millions or even billions of tons, they are often completely surprised. Clouds look so light and airy, it's hard to believe they could be so heavy. They appear soft and fluffy, like giant cotton balls or spun sugar, almost like something out of a dream. However, this is where our natural feeling about things goes wrong. Our eyes aren't good at figuring out the real weight of something, made up of many tiny parts spread out over a very large area. In 2011, some scientists carefully studied what looked like an ordinary white cloud calmly floating across the blue sky. It wasn't a dark storm cloud or a massive hurricane. It was just a typical cumulus cloud, like you'd see on any nice day. When they calculated its mass, the result shocked everyone. About 1.1 million tons. To understand how incredibly heavy this is, imagine the weight of hundreds of thousands of huge elephants, or several thousand fully loaded jumbo jets. What's even more amazing is that this cloud, despite its immense weight, wasn't even considered a very big one. So here's the obvious question. Where does all that weight come from? The answer is simple yet surprising. Clouds aren't just air, they're made of water, specifically tiny liquid droplets or microscopic ice crystals. Each of these droplets is incredibly small, even thinner than a human hair, roughly the size of bacteria. By itself, a single droplet weighs almost nothing. However, clouds hold billions upon billions of these tiny particles. Imagine a single grain of sand. It's light, but a desert full of countless grains is heavy. The same principle applies here. All these droplets add up. The secret lies in the sheer number of these tiny components. At this point, I know it may not still make a lot of sense, but just hang in there because we are about to reach the heart of the mystery. So, if clouds are made of water and water is heavy, and gravity is always pulling things down, then why don't these huge clouds just fall out of the sky like giant rocks? The simple answer is that clouds don't sit on top of the air like an object on the ground. Instead, they are a part of the air itself. To understand this, we need to think about density. Something floats not because of its total weight, but because of how dense it is compared to the fluid or gas around it. The air pockets inside its hull make it much lighter than the water it pushes aside. Similarly, even though a whole cloud has a lot of weight if you could collect it all, its parts are spread out so much that it is incredibly light for its size. For example, a common fluffy cloud covering a large area holds a surprisingly small amount of water vapor, only about 1 gram in each cubic meter of air. This tiny amount of water is even less than what you would get from a single sip through a straw. Air, by its very nature, possesses both weight and pressure, and it exerts an upward push. Clouds are an integral part of this dynamic atmospheric ocean. Imagine stirring flour into water. The flour particles don't instantly settle because the water's motion and resistance keep them suspended. Cloud droplets behave in a similar fashion. Each individual droplet descends at an incredibly slow pace, sometimes as little as 1 centimeter per second. Therefore, while clouds are technically always falling, their descent is so gradual that upward air currents effortlessly counteract the effect of gravity on them. Another very important contributing factor to this effect and to how clouds are formed in the first place is warm air. When the sun heats the ground, the air above it gets warm. Because warm air is lighter than cold air, it floats upward. As it rises, the air pressure goes down, causing the air to spread out and cool. Once it cools enough, water vapor turns into tiny drops, creating clouds. This means clouds are always being rebuilt from the inside and pushed up from underneath. It's like being in a crowd that keeps lifting you higher without you even noticing. Another common question that always comes up is this: if clouds are always slowly falling, why don't they constantly rain? The answer is that very small water droplets don't fall as rain because they are too tiny. For rain to form, these droplets must bump into each other, combine, and grow bigger and heavier. Only when they reach a sufficient size can gravity finally overcome the air pushing against them. So, rain isn't clouds falling, it's clouds failing. Thin clouds don't rain because the droplets never grow large enough. However, thick storm clouds do rain because the droplets inside them collide forcefully and randomly, leading to rapid growth. From another angle, many people out of curiosity often wonder why airplanes aren't crushed by clouds if clouds are so heavy. The simple truth is that airplanes don't actually hold up clouds, they fly right through them. A cloud's weight is spread out over many miles of air, so it doesn't push down like a solid object. It's similar to walking through fog. You don't feel the fog's weight because it's not resting on you. The air around us is much stronger than it appears. In fact, the air above you right now weighs about 10 tons per square meter. You don't feel this immense weight because the pressure is evenly distributed in all directions, and your body has naturally adapted to live within this atmospheric pressure. So, in a nutshell, understanding how clouds stay in the sky is very important. These amazing parts of our atmosphere are key to our planet's most vital systems. They greatly affect our weather and climate. Clouds create all kinds of rain, from light drizzles to heavy downpours, and they are where powerful storms begin. They also act like huge mirrors, bouncing a lot of the sun's hot rays back into space, which helps control Earth's temperature. At the same time, clouds act like a blanket, trapping warmth in our atmosphere and shaping the complex weather patterns around the world. Being able to predict big storms, understand the secrets of climate change, and ensure safe flights for airplanes all depend on a deep and full understanding of these wonderful, often ignored formations. High above us, these beautiful creations are more than just pretty sights. They are actually some of the most important and essential natural systems on our amazing planet. Clouds aren't breaking the laws of gravity. They are simply interacting with it continuously. The next time you spot a cloud floating above, remember, it holds tiny oceans and future storms. Something incredibly heavy is being held aloft by something invisible. This isn't magic. It's nature proving far more clever than it appears. Thanks for watching. If you have ideas for our next video, please share them in the comments, and we'll definitely attend to them. Thank you also for joining us on this journey of curiosity. Remember to like this video, subscribe to our channel, and keep an eye out for more eye-opening videos.